Hey, what's up everyone? Welcome to this video on asynchronous programming in C#. In this video, we will be exploring what asynchronous programming is, how it works, and how it can benefit your applications. We will also be looking at some code examples to help you understand how to implement asynchronous programming in your own projects. By the end of this video, you will have a good understanding of what asynchronous programming is and how to use it in your C# applications. Before we dive into the code examples, it's important to understand the basics of asynchronous programming. So async programming allows you to execute long-running tasks in the background without blocking the main thread of your application. This can be particularly useful when working with network operations or other tasks that may take a long time to complete. Now let's look at a code example to see how async programming works in practice. In this example, we will be using the async and await keywords to asynchronously download a file from the web. So first, we define a method called downloadFileAsync, and that can be created like this: public async and then task, and then download file async. This is going to accept the URL for the file to download as an argument, and then we have to write the code to download the file. To download the file, we are going to use the await keyword. So to do that, we can do something like this using where client, because we have to create a new HTTP client object. So HTTP client, and because we are using the using block, any kind of cleanup will be done automatically when the code execution will exit from this using block. So where data equals to await client dot get byte array async, and then we have to provide the URL as an argument. The important thing over here is to see that this is a long running process. Even if it is not a long running process and the file size is smaller, but then because it is a network request, we have to wait for the response to be returned from the network before we can use this downloaded file in our code. So await keyword will pause the execution of the method until the download is complete, and this allows the main thread of the application to continue executing rather than being blocked by this long running download task. Also, it's important to note that the async and await keywords can only be used with an async method. One common scenario for async programming is when working with user interface elements in a Windows Forms or WPF application. For example, let's say you have a button that when clicked performs a long-running task such as downloading a file from the web. Without async programming, the UI would freeze until the task is complete, which is not a good user experience. By using async programming, you can perform the long-running task in the background while still allowing the user to interact with the UI. Here is an example of how we can do that. First, we can add the click handler for a button like this. First, let's just disable the button so that multiple clicks can be prevented. Then we can perform the long running task like this: await task.run, and we can provide a long running task function execution as an argument. So let's just name that function as long running task for now. And then finally, when this task is finished, then we can again enable the button. Now for the definition of this long running task function, we can create a method like this. So private void long running task, and it can contain code for a long running task. So this is how we can use the async programming when handling the button clicks. Another common scenario for async programming is when working with databases. For example, let's say you have a method that retrieves data from a database and populates a list on the UI. Without async programming, the UI would be blocked while the data is being fetched from the database, which can lead to a poor user experience. By using async programming, you can retrieve the data from the database in the background while still allowing the user to interact with the rest of the UI. So we can modify this code example for this scenario, and instead of this long running task, we can fetch data from the database like this, where data equals to await task.run get data from database. And then for the method to get data from database, we can just create another one like this, which will simply contain the code to fetch our data from database. It's also worth noting that async programming can improve the performance and scalability of your applications, particularly when working with network operations or other tasks that may take a long time to complete. By using async programming, you can free up resources on the main thread, allowing it to handle other tasks while the long-running task is being executed in the background. In conclusion, asynchronous programming is a powerful tool that allows you to execute long-running tasks in the background without blocking the main thread of your application. By using the async and await keywords, you can easily implement async programming in your C# projects. Thank you for watching this video, and if you like its content, then be sure to subscribe to this channel, and I will see you in the next one.